punch tape or perforated paper tape is a form of data storage, consisting of a long strip of paper in which holes are punched to store data. Now effectively obsolete, it was widely used during much of the 20th century for teleprinter communication, for input to computers of the 1950s and 1960s, and later as a storage medium for mini-computers and CNC machine tools. Origin. The earliest forms of punch tape come from weaving looms and embroidery, where cards with simple instructions about a machine's intended movements were first fed individually as instructions, then controlled by instruction cards, and later were fed as a string of connected cards. This led to the concept of communicating data not as a stream of individual cards, but one continuous card, or a tape. Many professional embroidery operations still refer to those individuals who create the designs and machine patterns as punchers, even though punched cards and paper tape were eventually phased out, after many years of use, in the 1990s. In 1846, Alexander Bain used punch tape to send telegrams. In 1880s, Talbot Lanston invented a monotype system, which consisted of a keyboard and a composition caster. The tape, punched with a keyboard, was later read by the caster, which produced lead type according to the combinations of holes in 0, 1 or more of 31 positions. The tape reader used compressed air, which passed through the holes and was directed into certain mechanisms of the caster. The system went into commercial use in 1897 and was in production well into the 1970s, undergoing several changes along the way. Tape formats. Data were represented by the presence or absence of a hole at a particular location. Tapes originally had 5 rows of holes for data. Later tapes had 6, 7 and 8 rows. An early electromechanical calculating machine, the automatic sequence-controlled calculator or Harvard Mark I, used paper tape with 24 rows. A row of narrower holes that were always punched served to feed the tape, originally using a wheel with radial teeth called a sprocket wheel. Later optical readers used the sprocket holes to generate timing pulses. Text was encoded in several ways. The earliest standard character encoding was Baudot, which dates back to the 19th century and had 5 holes. The Baudot code was never used in teleprinters. Instead, modifications such as the Murray code, Western Union code, International Telegraphic Alphabet No. 2, and American Teletypewriter Code, were used. Other standards, such as Teletype Setter, File Data and Fluxo Writer, had 6 holes. In the early 1960s, the American Standards Association led a project to develop a universal code for data processing, which became known as ASCII. This 7-level code was adopted by some teleprinter users, including AT&T. Others, such as Telex, stayed with the earlier codes. Dimensions equals, tape for punching was 0.00394 inches thick. The 2 most common widths were 11/16 inch for 5-bit codes, as 1 inch for tapes with 6 or more bits. Hole spacing was 0.1 inch in both directions. Data holes were 0.072 inches in diameter. Feed holes were 0.046 inches. Paper tape rolls in both widths are still commercially available as of 2012. Chadless tape equals, most tape punching equipment used solid punches to create holes in the tape. This process inevitably created chad, or small circular pieces of paper. Managing the disposal of chad was an annoying and complex problem, as the tiny paper pieces had a tendency to escape and interfere with the other electromechanical parts of the teleprinter equipment. A variation on the tape punch was a device called a chadless printing reperforator. This machine would punch a received teleprinter signal into tape and print the message on it at the same time, using a printing mechanism similar to that of an ordinary page printer. The tape punch, rather than punching out the usual round holes, would instead punch little U-shaped cuts in the paper, so that no chad would be produced. The hole was still filled with a little paper trapdoor. By not fully punching out the hole, the printing on the paper remained intact and legible. This enabled operators to read the tape without having to decipher the holes, which would facilitate relaying the message onto another station in the network. Also, of course, there was no CHAD box to empty from time to time. A disadvantage to this mechanism was that CHADless tape, once punched, did not roll up well, because the protruding flaps of paper would catch on the next layer of tape, so it could not be rolled up tightly. Another disadvantage, as seen over time, was that there was no reliable way to read CHADless tape by optical means employed by later high-speed readers. However, the mechanical tape readers used in most standard speed equipment had no problem with CHADless tape, because it sensed the holes by means of blunt spring-loaded sensing pins, which easily pushed the paper flaps out of the way. Applications communications Punch tape was used as a way of storing messages for teletypewriters. Operators typed in the message to the paper tape, and then sent the message at the maximum line speed from the tape. This permitted the operator to prepare the message offline at the operator's best typing speed, and permitted the operator to correct any error prior to transmission. An experienced operator could prepare a message at 135 WPM or more for short periods. The line typically operated at 75 WPM, but it operated continuously. By preparing the tape offline, and then sending the message with a tape reader, the line could operate continuously rather than depending on continuous online typing by a single operator. Typically, a single 75 WPM line supported 3 or more teletype operators working offline. Tapes punched at the receiving end could be used to relay messages to another station. Large store-and-forward networks were developed using these techniques. Paper tape could be read into computers at up to 1,000 characters per second. The Danish company Regner Centralen has developed a paper tape reader called RC2000 that could read 2,000 characters per second. It was introduced in 1963. Later they increased the speed further, up to 2,500 CPS. Mini-computers. When the first mini-computers were being released, most manufacturers turned to the existing mass-produced ASCII teleprinters as a low-cost solution for keyboard input and printer output. The commonly specified Model 33 ASR included a paper tape punch reader, where ASR stands for Automatic Send-Receive as opposed to the punchless readerless KSR, Keyboard Send-Receive and RO, receive-only models. As a side effect, punch tape became a popular medium for low-cost mini-computer data and program storage, and it was common to find a selection of tapes containing useful programs in most mini-computer installations. Faster optical readers were also common. Binary data transfer to or from these mini-computers was often accomplished using a doubly encoded technique to compensate for the relatively high error rate of punches/readers. The low-level encoding was typically ASCII, further encoded and framed in various schemes such as Intel hex, in which a binary value of 01011010 would be represented by the ASCII characters 5A. Framing, addressing and checksum information provided error detection capabilities. Efficiencies of such an encoding scheme are on the order of 35 to 40%. Data transfer for ROM and EPROM programming. In the 1970s through the early 1980s, paper tape was commonly used to transfer binary data for incorporation in either mask-programmable read-only memory chips or their erasable counterparts, EPROMs. A significant variety of encoding formats were developed for use in computer and ROM EPROM data transfer. Encoding formats commonly used were primarily driven by those formats that EPROM programming devices supported and included various ASCII hex variants as well as a number of computer proprietary formats. A much more primitive as well as a much longer high-level encoding scheme was also used, BNPF. In BNPF encoding, a single byte would be represented by a highly redundant character framing sequence starting with a single ASCII B, 8 ASCII characters where a 0 would be represented by a N, and a 1 would be represented by a P, followed by an ending ASCII F. These 10-character ASCII sequences were separated by one or more whitespace characters, therefore using at least 11 ASCII characters for each byte stored. The ASCII N and P characters differ in 4-bit positions, providing excellent protection from single punch errors. Alternative schemes were also available where H and L, or 0, and 1 were also available to represent data bits, but in both of these encoding schemes, the two data-bearing ASCII characters differ in only 1-bit position, providing very poor single-punch error detection. Cash registers National Cash Register or NCR made cash registers around 1970 that would punch paper tape. The tape could then be read into a computer, and not only could sales information be summarized, billings could be done on charge transactions. Newspaper industry Punched paper tape was used by the newspaper industry until the mid-1970s or later. Newspapers were typically set in hot lead by devices such as a linotype. With the wire services coming into a device that would punch paper tape, rather than the linotype operator having to retype all the incoming wire stories, the paper tape could be put into a paper tape reader on the linotype and it would create the lead slugs without the operator retyping the stories. This also allowed newspapers to use devices, such as the Friedenflugschau writer, to convert typing to lead type via tape. Even after the demise of the linotype hot lead, many early offset devices are paper tape readers on them to produce the news story copy. Automated machinery In the 1970s, computer-aided manufacturing equipment often used paper tape. Paper tape was a very important storage medium for computer-controlled wire-wrapped machines, for example. A paper tape reader was smaller and much less expensive than whole-writh card or magnetic tape readers. Premium black waxed and lubricated long fiber papers, and mylar film tape were invented so that production tapes for these machines would last longer. Cryptography Paper tape was the basis of the Vietnam cipher, invented in 1917. During the last third of the 20th century, the National Security Agency used punched paper tape to distribute cryptographic keys. The 8-level paper tapes were distributed under strict accounting controls and were read by a fill device, such as the handheld KOI-18, that was temporarily connected to each security device that needed new keys. NSA has been trying to replace this method with a more secure electronic key management system, but paper tape is apparently still being employed. Paper tape canister. The paper tape canister is a tamper-resistant container from which the contents may manually be dispensed but which prohibits reinsertion of a tape once removed. It was used to securely distribute cryptographic keys. Distributing cryptographic keys in the open left the keys vulnerable. Putting tape in canisters solved a lot of the security problem by narrowing the vulnerability to the point of use rather than the whole time in inventory, said Whitfield Diffie. The canister was invented to prevent the ability to tamper with the paper tape once placed inside the canister. One of the primary users of the paper tape canister was the National Security Agency. The NSA needed the ability to transfer cryptographic keys in a way that clearly showed if the keys had been compromised. The paper tape canister has several tamper-proof design features. Marbling, Hugh V. Hayes, the inventor, wrote, "Every paper tape canister is unique. This uniqueness is accomplished during the manufacturing process. The plastic flowing into the mold creates unique flow patterns throughout the entire paper tape canister, thereby making it impossible to duplicate, eliminating the possibility of substitution. Welded seam. The welded seam ensures that the paper tape canister cannot be pried open without being detected. Beaded seam is a unique seam that is difficult to duplicate. Maze-like paper path. The paper path will not allow the reinsertion of tape. Limitations. The three biggest problems with paper tape were, reliability. It was common practice to follow each mechanical copying of a tape with a manual hole-by-hole comparison. Rewinding the tape was difficult and prone to problems. Great care was needed to avoid tearing the tape. Some systems used fanfold paper tape rather than rolled paper tape. In these systems, no rewinding was necessary, nor were any fancy supply reel, take-up reel, or tension arm mechanisms required. The tape merely fed from the supply tank through the reader to the take-up tank, refolding itself back into exactly the same form as when it was fed into the reader. Low information density. Data sets much larger than a few dozen kilobytes are impractical to handle in paper tape format. Advantages. Punched tape does have some useful properties. Longevity. Although many magnetic tapes have deteriorated over time to the point that the data on them has been irretrievably lost, punch tape can be read many decades later, if acid-free paper or mylar film is used. Some paper can degrade rapidly. Human accessibility. The whole patterns can be decoded visually if necessary, and torn tape can be repaired. Editing text on a punch tape was achieved by literally cutting and pasting the tape with scissors, glue, or by taping over a section to cover all holes and making new holes using a manual hole punch. Magnetic field immunity. In a machine shop full of powerful electric motors, the numerical control programs need to survive the magnetic fields generated by those motors. Ease of destruction. In the case of cryptographic keys, the inherent flammability of paper tape was an asset. Once the key had been loaded into the device, the paper tape could simply be burned, preventing the key from falling into enemy hands. Punch tape in art. A computing or telecommunications professional depicted in the Monument to the Conquerors of Space in Moscow holds what appears to be a punch tape with 3 rows of rectangular holes. Current use of punch tape today is very rare. It may still be used in older military systems and by some hobbyists. In CNC machining applications, what few existing installations remained in grandfathered use are now quickly disappearing as the advantages for new orders of old part designs are being superseded by natural economic evolution. However, some modern CNC systems still measure the size of stored CNC programs in feet or meters, corresponding to the equivalent length of punched on paper tape. See also, bit bucket, book music, CAD. Jacquard loom controlled by a system similar to, but not quite the same as punch tape. Key punch, music roll, piano roll, punched card, Zegelski sheets, a system used to decrypt messages enciphered on German Enigma machines. References: Dalakoff, Georgy, History of Computers, The Mark Computers of Howard Aiken, retrieved January 12, 2011, Prisch, Roland. Technical Handbook for Radio Monitoring HF, edition 2009. Books on demand. ISBN 3837045730. ECMA 10, Standard for Data Interchange on Punch Tape, November 1965, http, www.nksupply.com/ paper-tape-rolls.html, Hult, Shaw, Presentation of a new high-speed paper tape reader, BIT Numerical Mathematics 3, 93 doi, 10.1007/BF01935575, translation file formats. Data IO Corporation. Retrieved August 30, 2010. Sinha, Naresh Kumar. Microprocessor-based control systems. Pages 264. Paper tape is well suited to a machine shop environment, whereas magnetic tape may be accidentally erased or contaminated by foreign substances. Other disadvantages of paper tape are as follows. CNC control setup for milling and turning, Mastering CNC Control Systems, by Peter Smid, 2010, pages 20. External links, ECMA 10, ECMA Standard for Data Interchange on Punch Tape, a song mentioning paper tape, various punched media, Friedenflugschauwriter combination typewriter, paper tape punch, and paper tape reader, designed by IBM during the 1940s and bought out by Frieden in the late 1950s, Olympia Flugschauwriter, detailed description of 2 paper tape code systems, Baudot code and the system used by the ALL computer, a film clip Dead A-Bomb Hits U.S. Town, 195,813 is available for free download at the Internet Archive.